So this is the end of lesson 9.1. And in 9.1 you've been listening to several of his videos, and you still have, no, you already listened to the last one that I'm going to get you to listen to. So this is kind of going back to do a recap on the end of this section. So I'm on page 582. I do want you to note the information here. I know he has gone over the information. I think it's just good to make sure that you've got pieces and parts of this on your formula sheet as much as you want for reference during the next test. And so when you're putting these pieces and parts on there, you might want to make sure that you're making a note, and I like to put it in my notes as going from R to P. And that way I know I'm going from rectangular to polar. And then the same thing here, it's just a little bit more in depth, and again going from rectangular to polar. And then they give us a little bit more, and while I'm doing this, I like to go ahead and highlight that the step-by-step is the first thing we're going to do is plot, and then we're going to draw it. And then we're going to find R, and then we'll find or determine our theta. We'll determine the theta. And so I just re-highlight that here on page 582, where we plot it, we find our R, and we determine our theta. But I think this is a good piece of information here about which quadrant and when you need to go ahead and move it on around with an additional pi. What I want to focus on is this bottom part about transform, or two transform equations between polar and rectangular. He's going to talk, and you've already listened to his video about this. I just want to highlight a few more parts of it. And this part at the bottom of 582 is going from polar to rectangular. Hence, I like to write P to R, and that just helps my brain wrap around where we are. And he mentioned a couple of things. And so mentioning these common things, common techniques, we can multiply both sides by R. We could also square both sides, and to know which one to do takes practice, and on a test or on the homework you might square both sides and go, ick, don't erase it. Go the other way. Let me try it again, but this time let me multiply both sides by R. Familiarity with old formulas, things that we have seen, just having an idea of what you're looking at can be helpful. So when we look at this one that says let's transform this equation from polar to rectangular, I've got a couple of options. I can either multiply both sides by R, or I can square both sides. And when I look at this, if I square this side, I get a cosine squared. Well, that's good. It can get me to a 1 and a sine squared, but doesn't feel like it leads me anywhere. But if I happen to square this side, I get an R squared. And wait, that sounds really familiar, like, hey, R squared is worth x squared plus y squared. Oh, I can do something with that because I'm trying to go from r's and thetas to get it to x's and y's. I think I'll do that one. So I went off on the side, and I'm doing the same thing that they're doing. I just like to work through them myself. And so I've got my r equals 6 theta, and if I multiply this side by r and this side by r, then I'm going to go ahead and stick it in here, because I also know, is it here? Nope, it's going to be on the other place. Let me find where it is, because I just want to point it out. I also know that I got coffee cups all over the place. I also know that down here at the bottom, if I have an r cosine or an r sine, I can quickly change it over to x or to y, depending on which one it is. So when I go to multiply my r, I kind of go ahead and rig it. I could put the r here, the r here, the r here. But if I go ahead and write it as r cosine, that's going to be an x. So I'm going to change my r squared into its other value. I'm going to leave my 6 alone and then change my r cosine theta to an x. And we're done. And I think in the video he actually kind of stops about right here. Well, we are done. We have gone from r's and thetas to x's and y's, and so we are done. But wait, there really is more. Because in the directions it says, hey, let's go ahead and identify the graph. This right here doesn't mean a thing to me. So let me get my 6x over here. And let me go ahead and notice I've got an x squared and a y squared. And in college algebra, that could have meant several things. So let's play with it for a second. I do my x squared minus my 6x, and I left a gap here. Plus y squared equals 0. And then I did this good old thing called completing the square. Completing the square is where I take what's in front of my x, and let me just go up here. I take that negative 6, you can't even see where I'm writing, there we go, and I divide by 2 and I square. That's how you complete the square every time. Divide by 2 and square, divide by 2 and square. That gives me a negative 3 squared, otherwise known as a positive 9. But I need to remember that negative 3. It's going to come back in a minute. And so I need to add a 9 to complete the square of this trinomial. And it'll get me a binomial square. And if I add 9 to one side, I have to add 9 to the other side. So this x squared minus 6x plus 9 comes down to, remember I said we were going to need that negative 3 in a minute? Well, here it is. And there goes the coffee cup. X minus 3 squared. I still have a plus y squared, and then now I have a 9. And I have to recognize from college algebra or algebra 2 or somewhere in my former life, I have to recognize that that's the formula for a circle. And it's a circle specifically, not a negative 3, but we change it to positive 3, 0. This is the center of my circle. And then I take this side, and my r is the square root of it, which is 3. And if you look at the bottom of this problem, it goes ahead and finishes it up for us and says this is the standard form of the equation of a circle. The center is at the 3, 0, and the radius is at 3. I also wanted to look at example 9. Remember, unlike class, where you could ask me a question and I would stop talking, here you literally can hit stop and go back and redo that whole example 8 or just the pieces and parts that are fuzzy. But this is a great opportunity to learn everything that was just said in that example 8. You can see it, you've heard his version of half of it, and now I've added on to the rest of it. But now I want to go up here to example 9, because now it's rectangular to polar, r to p. So transform this equation from rectangular to polar. So we don't have those two tricks of multiply by r, square both sides. But what we do have is we know this. We know that if I have an x, I can slap in an r cosine theta. And if I have a y, I can do the same with an r sine theta. I have an x and a y. I got number, who cares, an x and a y. So I'm just going to go on over here, and again, they got the same thing going on this side that I have going on here. And so I put in that for x, that for y, and everything's good. So I can multiply my 4, my r, and get r squared cosine theta sine theta equals 9. And you see that I wrote, we're done. We are really done. We don't have to go any further because we have gone from rectangular, x's and y's, to polar. We've got r's and thetas. So we are really, really done. But wait, it could look a little bit better, and this is where you're going to have to keep in mind that we've done double angle formulas, half angle formulas, etc., etc., etc. And if we manipulate this just a little bit, if we pull a 2 from this 4 and leave 1, 2 here and split them apart, factor them, leave the r squared here, the cosine and the sine, that cosine sine looked really familiar, but it was just missing a 2. So a little bit of manipulation, and all of a sudden, we've got our 2r squared, but that 2 cosine sine is also known as the double angle for sine. And so this equation, 2r squared sine double angle 2 theta equals 9, is much better. And that's what they mention over here. So I just wanted to take a few minutes and go through example 8 and example 9, kind of tie some information together as we finish section 9.1.